All right, let's just jump right in. You've probably asked ChatGPT a question, right? And you've seen how it just gets what you're saying. Well, the magic behind that is something called the attention mechanism. And today, we're going to pull back the curtain on this idea. It comes from this one groundbreaking paper back in 2017 that pretty much changed everything for AI.
I mean, it really all boils down to this one big question, doesn't it? How does a machine, just a bunch of circuits and code, how does it actually understand the crazy, nuanced, context-filled way we talk? It feels like it should be magic, but the answer is actually a surprisingly elegant system.
Okay, so this slide right here, it just nails the core problem. You look at the word mole, and you instantly know it means three totally different things here. A little animal, a chemistry term, a spot on your skin. Easy for us. But for an AI, at first, it sees the exact same chunk of data for each one. It's just a string of numbers. We call it a vector. That's basically a dictionary definition. The AI has no clue which mole it is. So, how does it figure it out? It has to look at the words around it. The answer, of course, is context.
So here's how we're going to break this down. First, we'll talk about that context problem. Then, how attention is the answer. We'll dive deep into how one single head works, then pull back to see how many heads and layers create the whole system. And finally, we'll get into the mind-blowing power of scale. All right, so here's the fundamental challenge, right? A language model's entire job, its main goal, is to predict the very next word in a sentence. But to do that well, it can't just rely on dictionary definitions. It has to somehow take those isolated word meanings and weave them into a real, context-rich understanding of everything that's being said.
So the very first thing an AI does is turn every single word into a list of numbers. We call this an embedding. A good way to think about it is like a coordinate on a giant map of language, where words with similar meanings are neighbors. But, and this is the key part, at this initial stage, the coordinates for mole are the same no matter what sentence it's in. It hasn't looked at its neighbors yet to figure out where it really is.
And this is where the revolution happens. This is the big idea. The attention mechanism is the breakthrough that lets all those lonely, isolated word embeddings finally talk to each other. They can ask questions, they can share info, and they can start building that context they so desperately need.
So what is it really? Well, at its core, attention is basically a system for figuring out what's relevant. For any single word, it looks across the whole sentence and asks, okay, which of you other words are the most important for me to understand my job right here, right now? It's like giving the AI a super-powered spotlight. It can shine on the most important bits.
Okay, let's zoom all the way in. Time to get our hands dirty. To really get the whole system, we first have to understand the smallest moving part, just one single head of attention. And we're going to walk through it with a really simple example.
So imagine the model is trying to understand this simple phrase. What we want to see is the exact process for how the model figures out that Fluffy and Blue are describing the creature. How does it make that connection? Well, it happens through this really cool structured conversation between the words, and it's got 4 basic steps. First, a word asks a question, we call that the query. Then all the other words offer up potential answers, those are the keys. Next, the model scores how well each answer fits the question. And finally, the words that get the highest scores get to share their info, and that info is called their value.
So, first up, the query. The word creature creates this query vector, and you can literally think of it as the word asking a question, like, hey, is anyone around here an adjective that's describing me?
Okay, so then, every other word in the phrase generates a key vector. This is its potential answer. And the key vectors from Fluffy and Blue are basically designed to be a perfect match for the creature's question. It's like 2 magnets just snapping together. They're pretty much shouting, yep, I'm an adjective. I describe things.
And boom, this table shows you exactly what happens. The model takes the query from creature and compares it to the key from every other word. And where they match up, like with Fluffy and Blue, you get a high score. Where they don't, like with roamed or the, you get a low score. This pattern of high and low scores, that's the attention pattern. Okay, quick side note, but this is super important. There's this thing called masking. See, for the model to actually learn how to predict the next word, you can't let it cheat by looking at the answer key. So, when it's processing a word like blue, it's literally blocked from seeing any of the words that come after it. This forces it to learn the actual relationships, instead of just copying the answers.
So, we've got our high scores. Now what? Well, this is the payoff. The words that scored high get to share their information.
Fluffy packs up its meaning into a value vector, and that high attention score is like a permission slip. It says, go ahead, add your information to the creature vector. And just like that, the embedding for creature isn't generic anymore. Its internal meaning has literally been updated to include Fluffy.
Okay, so that's one conversation, one little back and forth. But just looking for adjectives isn't going to cut it for understanding real language. Language is more like a whole symphony of complex relationships. And for that, you need a full orchestra. And that's where multi-head attention comes in. The model isn't just having one of these little query key value chats. Oh no, it's running tons of them all at the same time, in parallel. So you might have one head that's an expert at finding adjectives for nouns. Another one is tracking who did what, the subject and the verb. And maybe another one's entire job is to figure out what a pronoun like it is referring to.
So how many is tons? Well, a model like GPT-3 runs 96 of these different attention heads, all looking for different things, all in parallel, all at once, inside just one processing block.
But wait, it doesn't even stop there. These entire blocks, each with 96 heads, are then stacked, one on top of the other in layers. So the newly updated context-rich word meanings from Layer 1 become the input for Layer 2. Layer 2 refines them even more and passes them to Layer 3, and so on. You can imagine the early layers figuring out basic grammar, while the later layers are starting to grasp much more abstract things, like theme or even sarcasm. The understanding just gets deeper with every single layer.
And again, you have to ask, how many layers are we talking about? For GPT-3, it's 96. 96 layers. So think about that. That's 96 attention heads all running in parallel, stacked on top of each other 96 times. The sheer scale is just, it's immense. And that, right there, is where the real magic begins to emerge. Which brings us to our final and maybe most important point. Because as clever as this whole attention idea is, its true power, the real secret sauce, is how this brilliant design makes it possible to scale up to an almost unbelievable size.
Let's actually put some numbers to this, because it's wild. A parameter is basically a tiny little knob that the AI can tune while it's training to get better. So, one single attention head, that's about 6.3 million of those knobs. One block with its 96 heads. Now you're at almost 600 million, and across all 96 layers, you get a staggering 58 times billion parameters. And that's just for the attention part of the model.
So why this? Why did this one idea completely take over the world of AI? Well, the ultimate stroke of genius is that all of those calculations for all 96 heads across all the words can happen at the exact same time. It's what we call highly parallelizable, which just means it's a perfect job for modern GPUs with their thousands of little computer cores. That one architectural advantage is what blew the doors open for scaling these models to sizes nobody thought possible. And it turns out just making them bigger seems to unlock these incredible new abilities all on its own.
And that really is the story of attention. It's an elegant idea, perfectly designed for modern computers, that finally let AI understand context simply by going massive. It was a huge, huge leap forward. And it leaves all of us with a really big question to chew on. If attention was the key that unlocked context, what's the next key we need to find? What's going to be the attention for even harder things, like genuine reasoning, or intent, or maybe even consciousness?